The story about kind of humanoid robots, I think, is 100% real. I'm very, very bullish on the future of humanoid robots taking over a lot of jobs inside of a facility that people don't want to do. That being said, my indications is that we're still quite a bit out from that process, and so there isn't this, there's not a ship coming to save us on this
Mm.
labor shortage situation. And so I think that you're going to still have to make these marginal improvements before we get to this wholesale change improvement that I do believe is coming with more humanoid robots in factories.
We're going through something absolutely historic.
Technologies across the board are growing exponentially.
It's a disruption that's going to completely redefine the way businesses compete.
In the next decade, we're going to lose 40% of today's Fortune 500 companies.
The exponential growth of computing is continuing.
AI is nowhere near its full potential.
Whether you like it or not, that the future cannot be stopped by anyone.
Hey everyone, welcome back to the Future Tech and Foresight podcast. I'm your AI host Mark Verbenka, and this is episode number 182. In today's episode, we dive into the intersection of safety, technology, and innovation in industrial environments. As more companies adopt intelligent systems and automation, the conversation is shifting from if to how we integrate predictive maintenance, electrical safety, and connected platforms into existing operations. It's not just about efficiency, it's about protecting workers, reducing downtime, and building smarter systems that evolve with your business. We explore the real-world applications of industrial IoT, from preventing electrical hazards to streamlining maintenance workflows. You'll hear how startups and established manufacturers alike are rethinking legacy systems, and what leadership really looks like in this new era. We also touch on reshoring trends, the importance of company culture in driving innovation, and what the factory of the future could mean for businesses trying to stay competitive. Whether you're a founder, engineer, or just curious about the future of industrial tech, this episode is packed with insights on how smart technology is reshaping the backbone of our economy. Now a little about our guest. Drew Allen is the president and CEO of Grace Technologies Incorporated. Under his leadership, Grace Technologies has solidified its status as a pioneer in electrical safety and predictive maintenance, consistently ranking as one of Iowa's top workplaces for the past 5 years. Drew serves on the advisory boards of Atom Power Incorporated, a company revolutionizing the power industry with the first solid-state circuit breakers, and Proxy, a company specializing in wearable safety technology designed to protect industrial workers from electrical hazards. He is also a member of the board of YPO Iowa, a global leadership community of more than 29,000 chief executives in 130 countries. Before becoming CDO of Grace, Drew started hosting the Factory Futurist podcast, where he engages with thought leaders and innovators in high-tech manufacturing. The podcast focuses on uncovering the secrets of sustaining high-performance leadership in technology, both professionally and personally. Hi there, Drew. Thank you so much for coming onto the podcast today to talk about, industrial precision sensors and kind of manufacturing in the general term. I think there's going to be a number of interesting topics that we touch on today. Thanks for coming on and exploring some of these topics with me today.
Hey, thanks so much, Mark. This is an exciting time to kind of be in the technology space. I've been in it for a while, but it just seems like the level of innovation, especially kind of on the backbone of this AI that we were talking about forever, is really exploding, and applications are just endless, and the field is very fruitful. So I'm excited to dive in with you today.
Yeah, for sure. Maybe we can take a step back before we dive into everything. I read on, and this is typically how I like to start the conversations. I read on your LinkedIn that you went to China, and that's how you got interested in tech, and I guess it led to the work that you're doing now. Is that a relevant place to start off to, bring the audience into, what you're doing now?
I'd say so. So the story goes back a little bit further than just China. My dad actually started the business in '91 as a system integrator, kind of focused on Rockwell automation solutions. And the product, our product business kind of came out of that system integrator. My dad is this one of these kind of born inventor types. And so at the dinner table growing up, it was always a conversation about how something works, what's the technology, taking things apart, maybe not at the dinner table, figuring out how to put them together, making rockets, those kinds of things. My dad, he started down this kind of inventor route, and that was in the vein of his great uncle Samuel Finley Breeze Morse, who actually invented the Morse code.
Oh, really? Oh, that's so interesting.
Yeah, and so my there's been like a running joke in the family because I think Samuel Morse had 6 patents or 7, and so the goal has always been for my dad to get 8, and then for me to get 9. I've only got 1 currently, but I think my dad just got his 9th, so I have to accelerate. I gotta pick up the slack. But basically, technology has just been always a topic of conversation in our family, especially being in the industrial automation space. And I went over to China for my first time when I was 13. And we went to go do a supplier visit. And let me tell you, you take a boy from the Midwest in Iowa and you drop him in the middle of Beijing. Your eyes are open. China was a completely different place back in 2003. I mean, it was just opening up, and it was the boomtown story. And so it really changed my perspective on life, on business, technology. And then, I ended up studying Mandarin in college, and eventually landed in Hong Kong kind of right after the recession. And that's where I started my career. And it gave me this just incredible vantage point of what technology looks like kind of from this hub in Southeast Asia. And then I took over the international side of our business. And so I was able to kind of see what were these trends that were emerging. And so I was able to see things happening in Europe. I was able to see things in mine sites in Australia and factories in Brazil, and work with the largest companies in the world. And so I kind of got this front row seat to the advent of this industrial technology and how to actually implement technology in a factory, which is like a lot different than installing an app.
Yeah, well, that's maybe a perfect place to start here. Like, what are the differences with, obviously industrial automation, but I'm also thinking like the audience here is probably very accustomed to apps and personal computing, but not so much familiar with industrial grade technologies and automations in general. Can you, as you have this great broad idea of what's going on in the world, like, can you maybe point out a couple like key differences between industrial tech versus consumer tech?
I would say that probably the first 2 laws of industrial technology adoption. One, industrial processes, once you get them working, you don't really screw with them. Okay. So that's typically a kind of a backbone. Don't fix what's not broken. And so, typically if there's an industrial process that's been working for 20 years and people are happy with it, they're really not looking to change it. Okay. Unless something has changed in the environment, the inputs, the expectation for the outputs, an increase in productivity, or some other external factor shifting that. The second is that industrial processes typically have high downtime costs.
Yeah.
So when you're looking at like, especially consumer grade applications, if it doesn't work, you're just pissed off. In a factory, in a process facility, you could be losing $1 million an hour. So you make one change, like maybe Sonos made to an app recently. Hopefully they're not a sponsor. And and all of a sudden you've just bricked a bunch of devices in a factory. Oh, well, if that's at your home, you just got a bunch of upset customers. Well, in a factory, you just costed them millions and millions of dollars. Right. And so I do think that you still see this early adopter kind of curve, right? I forget what the curve's called, but you got this population that's definitely early adopters. That tends to happen more in the R&D facilities, and there's only a certain number of really industrial companies that have super active R&D facilities for their factories. There's a lot of R&D facilities for the products they're making, but a couple come to mind. Procter & Gamble famously has CETL, which is like the Center for Engineering and Technology Leadership, and they work on all sorts of industrial technology in Cincinnati. Another one is Ford's Advanced Manufacturing Group. I mean, you walk in there and it's a playground for futurists. And there's definitely kind of those groups out there, but they try to do the experimentation over here before it gets really to the factory and get things hardened. So there is a bit more of an adoption curve. We typically find that when we launch a new product, that new product launches, in order for customers to become aware of it, it takes a while because it's a very diverse group of folks that we're marketing to. And so you start to get kind of sample requests in 3 months, 6 months. They install samples, they go ahead and test them out, and they want to get some runtime on them to see how the benefits are in their facility. And so maybe they roll it out on one machine. They want to roll it out for six months to 12 months to see how it works. And then they need to put it into a CapEx cycle. So you're really looking at like 2 to 3 years adoption. Even if I came into a facility and I said, I've got this incredible technology that's going to make everything perfect for you, and it's totally free, right? It's still going to take them a long amount of time in order to integrate that technology. And so it is a different world, but it's really cool because you're working with people who are really good and they really understand, if you're working at a steel mill, these guys know everything there is to know about how to make steel,
Sure.
And unfortunately, one of the big trends in our world is that those folks are retiring. I mean, I think it's a trend in every world, but and so that creates an opportunity.
Yeah. I mean, this is, as you said, this is a pretty large trend, right? There are these labor shortages. As I mentioned right before we started recording, like I lived and worked in Europe for about 10 years. And there was, every single project that we worked on with, industrial technologies, it was one of the main issues was always, well, there's a labor shortage. So let's try to figure out how to get robots or other types of, automation processes into these industries. And also, I guess it's not just these older people that are retiring, it's just that the younger people don't find these industries attractive anymore, right? It's I can't remember the percentage, but something like if you ask any American high school or elementary kid, like, what do you want to do when you grow up? It's like, 60 or 80% say, well, I want to be a YouTube, content
Influencer,
creator, right? Influencer or whatever. Yeah. So there's less interest in going into, these, essential jobs in these essential industries. So following from that, the question is there, with this labor shortage that you're obviously experiencing in Canada or in the States and the rest of the world, is there kind of a renewed or greater interest in automation technologies than there was, maybe during your dad's time?
Yeah, absolutely. I mean, I'm trying to think about how to actually break it down. There's definitely a dramatic increase in the amount of software tools available that are definitely a lot more user-friendly than what previous versions of that software that run on, that run the PLCs that run these factories kind of operate on. And there's all sorts of new tools. This story about kind of humanoid robots, I think, is 100% real. I'm very, very bullish on the future of humanoid robots taking over a lot of jobs inside of a facility that people don't want to do. That being said, my indications is that we're still quite a bit out from that process. And so there isn't this, there's not a ship coming to save us on this labor shortage situation. And so I think that you're going to still have to make these marginal improvements before we get to this wholesale change improvement that I do believe is coming with more humanoid robots in factories. I mean, I know that Xiaomi kind of famously has a YouTube video out showing one of their new dark factories and the humanoid robots that they've been kind of implementing. I don't have any specific data on that. I don't know what the reliability is. I don't know what their costs are, what their ROIs are like. So what you're really looking at is you're trying to identify processes that you believe are going to have a positive ROI. And for the most part, in a lot of industrial factories, robots, not humanoid robots, but typical 5-6 axis robots, those are going to cost you kind of $70,000 to $100,000 a sell, and you're typically looking at kind of a 2-year payback on a typical robotic project. 2 years is good, but I believe what's coming down the pipe is before the humanoid robots, we're looking at much, much cheaper overall 5 and 6 axis robotic systems that should be more in the realm of $20,000 to $30,000 with a vision system.
Okay.
And all of a sudden you're really more at a 3 to 6 month ROI. And so as long as you're able to maintain the quality standards and you're able to get your process re-engineered to fit that robot or redesign the product to fit what the robot can accomplish, you're going to be in a really good place, I think, in the next few years before, the Terminators take over. But there's a ton of other productivity improvements as well, and just ways to do things, safer and make things more productive. And that's kind of what we're all about at Grace is really doing that type of work before, everything's just completely automated. I will say this though, automation is a journey. And if you try to shortcut that journey and you try to go fully automated at your first go, chances are there's going to be a very, very high infant mortality rate of that project. I like to harken back to when Elon was trying to get the Model 3 off the line at Tesla in Fremont. They automated every single thing that they could figure out how to automate. And what ended up happening was they over automated. And when Elon was famously sleeping on the factory floors, they were ripping out ABB robots all over the place and replacing them with humans. Now I think that they've been able to automate the right things and then really fine tune the right automation for those more complicated tasks. And they've been able to speed up throughput to 70 plus jobs per hour, which is, I believe currently Tesla has the most car throughput of any factory in the world. But even Elon failed trying to fully automate on his first go. And this is making a car. Okay. We've been making a car for 100 years. Right. So
that's a really good point. Yeah. That's a really good point. Yeah. No, that's interesting. I remember talking about this in the earlier episodes of the podcast, right? I think we're up to like 175 or something like that now. And in the first 20 or so, I think that was one of the things that was happening. So we definitely talked about it then. But it's a really good point. How even, one of the most, you can call him one of the most automation focused guys out there wasn't even able to automate his car factory, and he was the one that was pushing for it, right? I remember these newspaper articles saying, world's first, fully automated or largest, fully automated factory out there. You mentioned Dark Factory, and I've talked about it on the podcast before, but for those that haven't heard of that, could you also touch on that? Because I think that's connected to what we're talking about right now.
Yeah. So dark factories, I guess the parlance actually comes from because there's actually no lights on in the factory, right? So because no humans are actually working in the factory, there is no need to actually have lights on. And basically inputs come in one end and outputs come out the other. And maybe they shut down the factory and turn on the lights, on a maintenance shift once a week on a Sunday or something. Yeah. But for the most part, the factories are operating independently. They tend to be more fully, automated, largely more process and not as much discrete automation. And those kind of factories are definitely more and more commonplace, but it makes the maintenance requirements much higher. And you really have to have a factory that has very pervasive sensing in order to operate so effectively without any human involvement. And these pervasive sensing technologies are becoming very widespread. Grace has an offering in the space, but I'm going to talk generally. I look at the world of pervasive sensing, and I look at it really from a idea of sensors everywhere, right? So on every wire, you've got a CT clamp and a voltage monitor. You have vibration coming off of motors and pumps and other rotating assets. You have flow meters and pressure valves, and you know where every air tank is, and you keep on sensing and more equipment so that you're getting more signals. The second there would be more and more vision systems. And these vision systems, as cameras have just fallen in price, and then you have the advent of the GPU, the ability to process vision data and really create more of a physical AI, and do that in a factory setting, is enabling a lot more automation as well. And all of a sudden, the tasks for learning based on the capability of both the GPUs as well as the libraries that NVIDIA is deploying and the neural nets, and then you combine that with a massive amount of visual data that's coming in, there's going to be way more physical AI data that's going to need to get processed than there was ever created by man in written form for LLMs. I mean, you just think about the resolution of a 4K image comparably to a 60-page, research paper. The LLMs are a nice trick, but the physical AI is a much richer data space. And so as that continues to kind of automate and you're able to really look at things, you get much better quality control. You're able to better monitor the factory, how things are moving, material flows, et cetera, because you have just all of these cameras looking all over the place.
So I mean, there's a lot of questions here falling from this. This is really interesting. Is the goal here essentially, whether we're talking about a dark factory or the factory of the future here, the role of the owner of this factory switches from getting kind of on the ground, helping his employees understand the certain tools to kind of dialing certain knobs, if you will. So because all this data is coming in, you're able to just make these micro adjustments to make things a little bit more efficient. I would assume that an entire process in these factories wouldn't necessarily need to be changed because all that stuff needs to be kind of thought out before an automated factory is put in place.
I think that if you're going through and you're investing that kind of money for a dark factory, you would hope that there would be some presets determined based on, so that you don't actually have to have the human dialing the knobs on and up and on. But usually these kind of speed versus quality decisions, right? So the faster a machine is running, typically you're going to get a higher amount of defects because there's wear surfaces that are running more cycles, and so maybe the gripper on the robot isn't as strong as it was 2,000 units ago. There's always a physical constraint. One thing about the factory world is you're working in a physical, physics based situation with materials. This isn't software just operating on silicon. This is like, oh, there's something real happening here. And so if you don't actually understand the underlying physics, you're going to run into trouble. That being said, I think that this creates a new level of job, right? And you're going to have these optimizers and these dark factories who are depending on what the customers are ordering and those kinds of things. They're running a much more supervisory position and probably approving what the AI or the predetermined rule matrix is actually telling you should be outputted, because things can get wonky and stuff's not perfect. it also makes the maintenance in that facility just, you have to have such highly trained maintenance people because you're dealing with a very complex system. The more complex the system is, even if it's super well designed, to keep all of that in your head and understand like where the inputs are and where the outputs are going and all of the steps of the process and how one thing interrelates to another thing. We were one of our product lines allows you to connect to PLCs to reprogram them, right? And I was actually in Spain on a sales call with a customer, and they were kind of giving me some pushback on the product. But they were like, we had an incident happen recently because some guy remoted into the PLC, and used kind of a VPN in order to remote into the PLC, and it was on a bottling line, and and he wasn't physically present. And it being Europe, it was Friday afternoon. So he gets a call from the customer. He makes the edit, something needed to get fixed. He makes the edit. He pushes publish. It goes to the PLC, and he goes away for his 2-week holiday, in Italy or wherever, and bottles start flying off the production line. Right. And because it was a Friday afternoon, he didn't really document the code changes he made because I'll just do that when I get back.
Sure.
So they had a 2-week shutdown. They couldn't reach the guy because his phone was off because it's Europe, as I'm sure you're well aware. And so now the idea is like, if you're going to make a change to the operating system of that machinery, you need to be physically present to actually verify it. Now I think with cameras and things like that, we can make that more abstract. But it's this idea of like, he didn't understand that simple code change that he was making was going to have an effect on that bottling line.
Sure.
And so if you don't have super highly trained, competent people, it's just going to end not in a great place.
Yeah, no, completely. I can only imagine the amount of not just time wasted, but money wasted and resources destroyed with a simple error like that. Is this something that the industry, and I know that there's like many different industries here, but that they're more and more concerned about as the, what do you want to call them? The old guard start retiring, right? There's going to be less and less competent people that understand how these things work properly. And there's kind of I would say a large fear that more and more of these problems are going to be happening if the automations in their plants aren't, properly understood and properly implemented.
I think it gets to what you were saying earlier about these jobs that people don't want to do.
Yeah.
So if you're in a really nice, clean, air-conditioned pharmaceutical area that's very highly paid, you know what? They're finding people. Eli Lilly's not having a hard time hiring, the best and brightest, right? It's the steel mill where it's 150 degrees, when you're walking around and you're in front of the furnace. It's the stamping facility, where there's oil dripping on your head. It's the mine site. It's it's these areas that are like not ideal, air conditioned, clean environments where I think that they have the most attrition of those skilled personnel. And also the process has been around a long time, but it maybe hasn't been documented as well as it should be. There's a lot of, in pharma, the process documentation is like extreme. I mean, that and airplane manufacturing probably have, the two highest levels of actual documentation for any sort of like industrial process. But probably a steel mill, like, especially if you're like converting steel into rebar and things like that, I would venture to guess a lot of facilities would say that their documentation is not, up to code.
Sure.
And I think that is, I think those are the type of industries that you first see that kind of brain drain in, and where they start to have issues and where they're trying to really solve those problems. Incidentally, those facilities are really important for America and really important for the world. And so it does feel like a problem that we need to actively solve.
Yeah, yeah, no doubt it could be like a critical problem that needs to be solved kind of as quickly as possible. Um,
Did you
one,
read that? Sorry.
yeah,
Did you
no, go
read
ahead.
that? There was an article in the Wall Street Journal recently. Did you
Mm.
read that? It was about this gal who graduated from engineering school and took a job with ASML.
No, I didn't.
So it was a fascinating kind of expose about the machine technicians for ASML. And these machines are 100 to 300 million dollars a pop, right? But the level of complexity of these I forget what the word is before lithography, some whatever special
Hmm.
lithography
Hmm.
process that ASML employs. Like you have to be small because you have to be able to like get into the
Sure.
machine. And so that like self-selects out this whole group. You have to have this like incredible mechanical aptitude because, you're there on site and you have to just sometimes make do with whatever is there if there's not parts available. And every hour that this machine's down isn't producing like $1 million of chips. I mean, it's this like crazy, crazy thing. But these companies that are doing it well, like that's a really complex environment, but they have, it's a great place to work, good pay,
Mm,
air
mm.
conditioned, very clean. Um, you know, but some of these other industries just it's not quite the same thing.
So really what you're saying here, if I'm reading between the lines, is that the robots are needed, right? There's this maybe interim period where there's a lot of other types of automations that are essential, but at some point it's not going to be the robots that are going to be taking all these jobs. It's going to be the robots that are going to be essentially supporting the continuation of a lot of these industrial processes.
Yeah, I just don't see how I just don't see without incredible amounts of investment, especially in these core
Mm,
industrial industries, um, without advancing of automation, I don't see how it works in the future. And I
mm.
just don't believe that we can offshore all of the jobs that we don't want to do.
And
Yeah.
especially with this reshoring movement that has been, talked about, I don't know, you're maybe over a decade or something, right? There's this desire to bring back, I mean, with Trump in America now. I mean, we're also recording this on the inauguration day, right? So there's going to be probably a larger reshoring effort, I would assume, but there's been this desire to move away from offshore manufacturing, bring it back to Canada, to the States, to Europe. And if there's not the labor base there, then automation really is kind of one of the only ways to have this trend continue. I would imagine.
Yeah, yes. I mean,
Hmm.
the one counterpoint I would put to that though is, so I was having a conversation on a recent trip to China, and one of our board members actually owns some industrial distribution businesses in China, and we were having a conversation about how the Chinese actually see technology very different than Americans.
Mm,
And so one of the big differences is that, remember when I said once we get that process working, we never want to change it.
yeah.
So
Yeah.
if I install something, I want it to work for a long time. In China, that's not the expectation.
Hmm.
So I would say it's like the equivalent of fast fashion,
Hmm.
but fast technology, because their belief system is that things change so rapidly in China, which has definitely been the case for them over the last 30 years, right?
Hmm.
Things change so rapidly that they don't want an old piece of technology running their machine for the next 20 years. They're fully anticipating just tearing that PC, that PLC, that drive out in 3 years.
Hmm.
So what's important to them is that it's low cost, because they know that they're going to rip it out in the future because the next version is going to come along and it's going to be Moore's law better, right?
Yeah. Yeah. Yeah.
And so what that's actually created is a very robust automation network in China at very low cost, doing a lot of things and automating a lot of processes, even in the midst of the fact that they still have one of the largest populations in the world. And yes, I know that the Chinese labor shortage is a story,
Hmm.
but in some ways they're kind of beating us a little bit on the automation game as well. which is really surprising because they're iterating so much faster.
Right.
So we're not iterating on that process. We were happy with that process that we put in 20 years ago, and we've been just fine tuning the knobs. In China, they're making giant leaps every 2 to 3 years because of the pace of innovation there. And so I hope, and I think in our company, iteration is so important, especially in our product design. We try to get to prototype as fast as possible, right? And I would really push folks here, like listening, that if you're involved in a factory, you have to be able to figure out how to iterate your processes faster. Like you can't come in with this mindset of like, I'm just going to install something and it's going to work for the next 20 years. I'm not going to touch it again. We have to figure out like, how do we get things that are a little bit lower cost, that we're going to be going on more of a 3 to 5 year cycle. Think a car, don't think an aircraft. In a lot of these facilities, and then that gives the newer generation an opportunity to actually like put their stamp and their thumbprint on the technology that's actually being installed instead of inheriting this like antiquated process.
Right. Right. Yeah. And I would also assume if there's this mentality of keeping, some large machine around for 20 years, that might become kind of a core part of the factory process, which if you can't change that, then you can't really adapt to the new, whether it's a new product or if there's something broken, right? You have to really stop everything because this one thing needs to be taken care of. And you can't, I guess I said you can't really adapt to these new things, these new conditions that are coming around.
And it becomes harder to fix.
Yeah.
All of a sudden the components that you had aren't available.
Right.
There's definitely a lot of things, whereas like maybe if we put on that hat of like, how do we re-engineer these processes, try to look at cheaper, faster automation systems that enable faster iteration. I think it gets you to that portion that Elon and SpaceX are on now. Instead of trying to automate everything the most expensive, highest end way, we're going to start off, but we're just going to iterate the fastest to get kind of to the future. I think that American companies, like that would be my challenge to you guys, North American companies, we got to iterate faster. We got to figure out how to shrink this adoption window from that, from 2 to 3 years. We got to be able to shift it down to 12 to 18 months, get things in, try things, and innovate. I think that's going to make ultimately our factories more competitive if we're able to really adjust to that approach.
Right. And do you think that the key to making that happen is this cultural or mindset shift, like understanding what, China, which is, I think for the next 4 years at least, is going to be seen as a much larger competitor than, I guess it was pushed in the media over the last 4 years. Is that kind of the key to this cultural shift, like understanding that your competitors are doing something different and it's working and it's going to keep working in the future compared to what, all of us in North America and most likely Europe are doing? Or is there like some other kind of, again, mindset or cultural shift that needs to happen? Like, I'm thinking newer people, new blood, new thoughts come into the industry and the older types don't hold things back.
Look, I think the Band-Aid right now is the tariffs. Okay. And so the tariff is holding off an onslaught of very cheap devices. I'll use a market maybe everyone here or it can is more accessible. The EVs.
Sure.
Right. So in the US, we basically have one EV brand, maybe two if you count Rivian.
Mm-hmm.
In China, there's like 20.
Right.
Okay. And the quality is better than my dad's Model S. And it's for $20,000 to $30,000 a car, not $90,000 a car. The thing is that there's barbarians at the gate, right? Where there is a lot of competition that just hasn't quite been able to access the U.S. market. It's happened in Mexico, by the way. If you go down to Mexico, the amount of BYD EVs are just exploding and they're taking over the market. This is let's not just only focus on competing because we have tariffs. We got to focus on having the best, lowest cost offerings because we're the smartest in how to automate these systems. If you're a VP of manufacturing, spend less time lobbying for the tariffs and more time like reshifting your company. Get some people to come in and do Scrum, right? Move the skills that we've developed in the software world in Silicon Valley over the last 20 years, and let's start putting that on the factory floor. Let's enable every single worker on the factory floor to be able to iterate every day, right? How do we create a platform where, Mark Zuckerberg famously went from like move fast and break things to we want to be the best place for a developer to come and the fastest place to build.
Right.
Let's be the fastest country to build. We have to increase our speed of iteration for us to be competitive in long term.
Super interesting. Yeah, I think, well, I'm in Canada here, but you guys certainly have a significantly larger manufacturing base. I think it'll be quite interesting to see if any of these change, not to get political at all, but to see if there's any kind of changes to this that happen over the next 4 years, because you're also reminding me of a lot of these ideas that I was discussing with my colleagues over in Europe quite a bit. It was like, yeah, this is actually a pretty critical issue for the nations that that manufacture quite a bit. And I think it's thanks for coming on to explain these sorts of things. It's very important.
Yeah, my hope kind of for the next 4 years is I'm hoping permitting gets a lot easier so that we are able to build factories. But, there's discussions of, Canadian energy specifically. I was just at a National Association of Electrical Distributor conference, and I know that this is one of their kind of key lobbying points. We have to be able to permit factories faster, but we have to also be able to permit energy production faster. And I'm not going to get in the political thing about oil versus wind versus solar. Like I know Trump's very against wind. We're in Iowa. Look, we have plenty of wind. I don't know. It seems to work fine to me, but maybe he knows something I don't. But the main thing is that we're going to have 35 gigawatts of energy production that needs to come online in the next 10 years, to fund the energy needed for the AI revolution, but also these factories, as they're automating, they're going to need much more power as well. And so, if we have to be able to build factories faster, we have to be able to build utilities, we have to be able to build all types of energy facilities. We are in a very competitive situation globally. And so speed matters. And if it takes 10 years to get a permit, you're like, how do you compete? And so that would be, if I'm going to come out with a political thing, in order, like we need to be focused on speed. Speed is really critical here. Speed, technology. I'm very bullish on America, but we gotta crank up the speed a little bit.
Yeah. Well, definitely not a discussion path that I thought we would go down to, but interesting, and I think important nonetheless, right? We only got some 10 minutes or 9 minutes or so left. We did discuss safety issues and how it relates to this automation thing, and we've completely passed that over. Should we touch on that just for a couple minutes? I think we've touched on the factory of the future and what the future is enough, and maybe we can just have this as kind of one of the last points here.
So it turns out by increasing automation in a factory, you're increasing two main drivers of safety concerns. So first of all, you're increasing the amount of power that's going into a facility. As you increase the amount of power, you introduce a lot of additional shock hazards as well as arc flash hazards. Arc flash specifically is determined by the current squared times time that the current operates for. So that gives you your calories per centimeter squared. So as you're adding more machinery, you're adding a lot more amperages of service And so you're creating this like much higher arc flash incident energy level. This is also happening in solar fields because obviously the kind of the higher the voltage, the higher the current, things run more efficiently. So we're creating electrical safety hazards. We're also creating a lot more interactions between humans and machines. So until the humanoid robots take over, and until we really figure out how to do maintenance by machine, meaning machines are basically taking care of other machines, there's a lot of lockout takeout related injuries and risks, crush risks, thermal risks. Hey, the machine starts with my hands in it. Those kinds of risks, or a robotic arm isn't properly gated, and so it's swinging around, it hits you in the head. I mean, these kind of incidents happen all the time. And so at Grace, we're really trying to address those. We're trying to address that market and really keep people going home at the end of the day, at least until the Terminators take over. I don't know.
Yeah.
I'm not sure I have a plan yet for when the Terminators take over.
Just ask ChatGPT, right?
Yeah, right. Hey, what does Grace's business model look like when there's no humans involved in manufacturing anymore? So we try to do that by creating things that are both simpler and safer and more productive. We think that people want to be safe, but they also want to be productive. And so if you're able to kind of create that win-win, we usually see a lot of buy-off by both like the operations groups as well as like the health and safety guys. They're like, oh, this helps me. This also helps me. Perfect. Let's fund it. And I think it's critical as we're automating that these safety issues are going to come up. And hey, that's what we spend all day kind of thinking about is how do we keep people going home at the end of the day? And we have a lot of employees who have had family members that have gotten hurt or something's happened or there was a near miss. And one of the products we just released is a new wearable product that senses voltage as you get close to it. And so it gives you an alert on your wrist. So it vibrates, it beeps, and it lights up and lets you know, hey, voltage is present before you touch that wire. I think that those are just practical innovations that keep people safe. And hey, like those hard industries that we were talking about earlier, hey, we're investing in our workforce. We want you guys to be safe. We care about you. That goes a long way to attracting the best and brightest back into these core industrial processes that are so critical to the future of America.
Yeah. No, super interesting. I'll have to have my editor put a picture of that wearable in when we're talking. That's super interesting. I hadn't thought of it, but it makes total sense. And this idea of, if these industries aren't attractive to the younger generation, then maybe things like this might get some people. Oh, well, there's not just an AC controlled environment, but there's also kind of a safer environment. You don't want to lose an arm or have anything crushed or anything. Oh, perfect.
So this is the wearable right here. My trusty media guy just dropped it off on my desk, but yeah, there he is. So it's just very simple. You just wear it. It's very cool. Really tight piece of technology. So
yeah.
No, I know it's black on black.
And it looks great too. Yeah.
Yeah. But it's got a dashboard. So the other thing is it's got a dashboard, which everything always has a dashboard. But what's cool here is that if you have like electrical contractors out on site and you start to get a lot of alarms from their bands that indicates that they're getting close to voltage, you're actually able to have proactive steps and like send someone over there and go, hey, are we not locking stuff out? Why are we getting so close to voltage? Is there some way to re-engineer this process that reduce the overall risk profile? And, you've got 900,000 IBEW members in North America. And there's incidents every day and there's near misses that go unreported. And, we're just super passionate about people being safe.
Right. Well, if that's one of the key components to having this whole reshoring movement be successful in America and, obviously in other Western countries, then thanks for coming on and sharing that.
No, hey, Mark, hopefully we didn't go too off the wall here. I hope your listeners will get
it was different than what I expected, but I think it was really interesting. It was honestly a little bit more in line with what I'm interested in. So it was great conversation. I will definitely put your website and I think some of the products that you have into the show notes.
Sure.
Are there other places that you want people to follow your company and what you guys do, like posting on LinkedIn maybe a little bit more often or whereabouts?
Yeah. So my two asks would be connect with me on LinkedIn. I'm relatively active there. But if you're thinking about a product, Grace is passionate about turning ideas into products and getting them out because we see so much opportunity in this industrial market. We've been at it. We know how to productize ideas. If you've got something that you've been thinking about for a while, contact me. I would love to work an idea. We actually have an accelerator here in Davenport called Maple Studios to turn kind of those hardware ideas into products. And if Grace is maybe the right channel partner for you, we'd love to partner on it. But I'd love to hear where you guys think innovation could happen in the factories, and maybe there's some areas I'm not seeing, and I would love to partner with you on it.
Awesome. I think that's a perfect place to end the discussion. Thanks so much for coming on, Drew. Really interesting. And maybe I'll have to have you back on at the end of 4 years and see what actually happens.
Thanks so much, Mark. I appreciate it.
A pleasure. Thanks. Well, thanks for listening to this week's Future Tech and Foresight podcast. If you like what you've heard here, there are, of course, a number of ways that you can support the podcast. The best way would be to leave a review on Apple Podcasts or give a rating on Spotify, which you can find a step-by-step explanation for on the futuretechandforesight.com website. Alternatively, feel free to leave a comment either on the episode show notes or the YouTube channel where you can see video recordings of the interviews. And finally, if you are part of an organization that is aware of the disruptive and transformational impact that emerging and future technologies will bring and want to know more, please get in touch to hear about the strategic foresight services that we offer and how we can help future-proof your organization and take advantage of the phenomenal opportunities available to survive and thrive in the future.
A lot of future-shocked people and future-shocked institutions in our society are simply overwhelmed.
Once there is superintelligence, the fate of humanity may depend on what the superintelligence does.
Science fact is catching up to science fiction.
The first truly intelligent machine will be the last invention that humanity needs to make.
The only scarcity that will exist in the future is that which we decide to create ourselves as humans.
Within a 10-year design revolution, we can have all humanity living the highest standard of living anybody's ever known.
Progress is accelerating at an exponential pace, and it's going to reach a point where progress is so fast it's going to be a singularity.
We are probably one of the last generations of Homo sapiens.
Every single headline points to the birth pangs of a Type 1 civilization.